This is tutorial question 2. An open tank has a vertical partition and on one side contain gasoline with a density equal to 700 kg per meter cube at a depth of 4 meter as shown in figure 2. A rectangular gate that is 4 meter high and 2 meter wide and hinge at one end is located in the partition. Water is slowly added to the empty side of the tank. At what depth H will the gate start to open? So this is the H in this situation. So in this question, what you need to understand is we have two fluid and these two fluid share the same gate. But you need to understand that we need to calculate two resultant force. One is from the gasoline and another one is from the water. And when you calculate the resultant force from the water, you need to consider the submerged area for water only. And then when you calculate the resultant force for gasoline, you will consider the submerged area for the gasoline here. So means that even though the gate is the same, we need to refer to the water level or the weighted area for each fluid. So the calculation can be like this. Okay, first for the right side, okay, we could draw the gasoline level here. So and then we determine the centroid for the submerged area. Let's say the centroid for the submerged area for the gasoline is here. So and then we could draw the resultant force for gasoline just below the centroid like this one. And then we could draw the distance of YR is here. Means the distance from the free surface to the FR. So and then we could calculate the distance of the HC, mean the distance of the centroid here to the free surface as here. So and then for the water side here, so we just draw the water free surface here. So we mark the submerged area and we assume this is the centroid for the submerged area. So and then we draw the resultant force due to water just below the centroid, and this is the length of dyr. So this is dyr, and from this centroid to this free surface is the length of HC. So and then we could calculate the resultant force due to the existence of water by using the equation of rho g HCA. And then in this situation, because the question here need to calculate the value of H, so we could calculate the HC here is H divided by 2, and the area here is 2 times H. So 2 meter here is the width of the gate. So and then we could calculate the YR by using this idea. So here is the moment of inertia. So we know that the gate is rectangular, so we use the idea of 1/12 AB cubed like this one. So and then we could calculate the value of YR for water is equal to 2/3H. And then we could calculate the resultant force for gasoline as this one. We know from the calculation here, the height here is 4 meters, so mean HC is equal to 4 divided by 2. So we use the idea of 4 divided by 2 as HC, and the area here is 4 times 2 because the submerged area is 4 meter and the width here is 2 meter. So we could calculate the YR for gasoline like this one. Okay, I hope you could do your own study to use the idea of moment of inertia from this equation. So we could calculate it like this one, and then we could get the YR, mean the distance from the free surface to the resultant force due to the gasoline here is 2.67 meter. And then we need to understand that, back to this diagram, we have a hinge at bottom here. So means when we have hinge here, we need to calculate according to the rotating moment. So the idea of rotating moment is now, so we need to multiply the force and the distance from the hinge. So it will become, on your left side here, it will become resultant force for water times the distance of A, so it must be equal to the resultant force for gasoline times the distance of B. So by hook or by crook, we need to know what is the distance of B and A here based on our previous calculation. So this is the general equilibrium for rotating moment. So we substitute the value of resultant force due to water and the distance of A. So the distance of A is actually the distance at the bottom here. So means that we get the total height of this one, mean the H, and then we minus with YR. So that's why we write here as H minus 2 over 3H. And again, this is the value of resultant force for gasoline, and this is the distance of B, 4 minus 2.67. If we calculate, we could get the height of H is 3.55 meter.